In this video, we'll learn how to determine the equation of the tangent. So let's say we had the polynomial y equals x cubed plus half x squared. And we're trying to find the tangent at the point x equals 1. So our first step is to substitute x equals 1 into the equation. So y equals 1 cubed plus half 1 squared, which is equal to 3 on 2. So the point 1 and 3 on 2 is a point on the tangent. Our second step is to find the derivative of the original function. So the derivative of x cubed plus half x squared is 3x squared plus x. And our third step is to substitute x equals 1 into the gradient function. So we get y is equal to 3 times 1 plus 1, which is 4. Therefore, we can say that the gradient of the tangent at x equals 1 is 4. So, the equation of the tangent will be in the form of y equals mx plus c, and m would be 4. And to calculate our y-intercept, we would need to substitute the points 1 and 3 on 2 into the equation to find c. So we get 3 on 2 equals 4 times 1 plus c. Therefore, c is equal to 3 on 2 minus 4, which is negative 5 on 2. Hence, our equation of the tangent is y equals 4x minus 5 on 2. Now, the reason we substitute 1 on 3 on 2 is because let's say the function looks like this, and our tangent is right there. And we said that this point was 1 and 3 on 2. Okay, so therefore, we know that this point is a point on the tangent, which is why we can substitute it into the equation to find c. Now, another way of doing this is by using a equation or a formula looking thing. So the formula goes, the equation of the tangent at x1, y1 is given by y minus y1 equals the derivative of f x1 times x minus x1. So if we do our previous example using this formula, we had the equation y equals x cubed plus half x squared at point x equals 1. So our first step is to find x1 and y1. And to do that, we substitute x equals 1 into the equation. So y equals 3 on 2. Therefore, x1 equals 1 and y2 equals 3 on 2. Y. Okay. Our second step is to find the derivative of the original function. So the derivative is 3x squared plus x. Next, we need to find the value of fx, the derivative of x1. So we're trying to find f1. So if we substitute f1 into 3x squared plus x, we get 3 times 1 plus 1, which is 4. So we have the value of the derivative of fx1, and our x1 and y1, and so we can substitute it into the equation and find the equation of the tangent. So we substitute the values in. Y minus 3 on 2 equals 4x minus 1. If we rearrange this equation, it becomes y equals 4x minus 4 plus 3 on 2, which is equal to y equals 4x minus 5 on 2, which is the same equation we got with our previous method. Okay, let's do one more example. Now this says, find the equation of the tangent to y equals x cubed, x squared, so it's quadratic, at the point 1, 1, and the equation of the tangent, and the equation of the tangent, y equals 1 over 6 x cubed at the point 2, 4, 3. Show that these tangents are parallel and find the perpendicular distance between them. Okay, so let's find the tangents first, the equations. So here, x1 is 1 and y1 is 1. And here, our x1 is 2 and y1 is 4 on 3. The derivative of y equals x squared is y equals 2x. And if we substitute x equals 1 into that equation, we find that y equals 2. And therefore, the gradient at point x equals 1 is 2. And therefore, our equation would be y minus 1 equals 2x minus 1. So y is equal to 2x minus 2 plus 1, and therefore it's 2x minus 1. Second example, the derivative of that function is y equals half x squared. And if we substitute x equals 2 into that equation, we get y equals 2, and therefore the gradient is 2. So our last step is to write the equation out. So y minus 4 on 3 is equal to 2x minus 2. We get y equals 2x minus 4 plus 4 on 3. So y equals 2x minus 8 on 3. So our final step is to prove that these two equations are parallel. And we can do that by saying the gradient m1 equals m2. And therefore, the two equations are parallel. Okay, and part C. Well, the last step is to find the perpendicular distance between them. To find this, we need to consider the normal of the two tangents. So the normal has a gradient of 1 on m. Therefore, the gradient would be negative half. And the normal, it's a line that passes through the tangents perpendicularly. So it's like that. So if we say that we had a normal that passes through the point 1, 1. So the 1, 1 is from here, this 1, 1. Then the equation of the normal would be y equals half plus c. Substitute 1 and 1 into the equation, and we get c equals 3 on 2. Therefore, our equation of the normal would be y equals negative half x plus 3 on 2. And so our next step, so let's say that's the tangent. Now that's the normal we have. And we want to find the point where the normal cuts the second tangent. And to do that, it's kind of like simultaneous equations, but we make this equal to 2x minus 8 on 3, because that will find the common point where they intersect. So negative half x plus 3 on 2 equals 2x minus 8 on 3. So that would be negative 5 on 2x equals negative 25 on 6. So x should be equal to 5 on 3. Now we'll continue this in our next page. So our next step is to substitute x equals 5 on 3 into the equation 2x minus 8 on 3 to find the y coordinate. So y is equal to 5 on 6 minus 8 on 3. No, sorry, that should be 10 on 3. So we get y equals 2 on 3, and we know that the tangent, so if we have the two tangents like this, if this is 1, 1, and here's the normal, it's perpendicular, then this point is 5 on 3, and 2 on 3. Okay, This diagram is completely wrong because this thing should be on the right side, but that doesn't matter. What we're trying to do here is use the distance formula to find the distance from this point to this point. So I'm trying to find this. So using the distance formula, you get square root of 5 on 3 minus 1 squared plus 2 on 3 minus 1 squared. So that's equal to 4 on 9 plus 1 on 9, square root of 5 on 9 plus minus, which is equal to the square root of 5 on 9. Since distance can't be a negative value, we can conclude that the perpendicular distance from the tangent y equals 2x minus 1 to y equals 2x minus 3 on 8 is square root of 9, square root of 5 on 3. That should be a 3. So that's how you find the tangent of the line and solve harder problems involving the normal as well.